finally, are we all ready for the last session of the day? We have Mr. Sandeep Batra, who is presently Executive Director, NHPC Faridabad. He is a civil engineer from GB Pant University and had joined NHPC in the year 1989. He has extensive hands-on experience right from survey and investigation, design, construction to operation and maintenance, including renovation and modernization of 36 years of several NHPC projects, out of which some are the 1000 megawatt Siom HE project, 2164 megawatt Chenab Valley power projects, Jammu 2000 megawatt Subhan Siri HE project, and various other hydropower projects. I welcome sir on stage to take our final session for the day.
Good evening, everyone. Last session of the day, so probably a little tired, but I hope that this session will be interactive and you will be participating in it. Just to start, if we can have a small introduction, where you come from, what you do, that will help me in
Hello, good evening. CA, working in Regulatory Affairs Division.
where?
Regulatory Affairs.
Regulatory affairs. Again, same E&C
Yes.
vertical. We can pass on, please.
Good evening, sir. My name is Muhammad Sharif, working in distribution company as superintendent engineer.
Where?
In Ballari, sir. Gulbarga Electricity Supply Company, Karnataka.
Okay. Discom, is it? Discom.
My name is Rajshekhar, working in Bescom Corporate Office, Bangalore.
Bangalore. Discom.
Yes.
Sir, I am Rajiv Adlakha. I am Executive Engineer in MP Transco, Jabalpur. Presently, I am in the commercial section.
At Jabalpur.
Yes, as Transco.
MP transmission.
MP Transco, sir.
Transmission assets.
Good evening, sir. Myself Nikita Lave, and I am an assistant engineer in Madhya Pradesh Power Transmission Company. And
Same organization.
Yes, sir. And at there, I am looking energy accounting of RE generators. Energy accounting of RE generators.
RE generators.
Yes, sir.
I hope you found all being discussed, which is being discussed, relevant to your work. Yeah.
Sir, good evening, sir. Myself is Shivaji Kare, Office SC, in HESCOM in Belgaum local. Sir, I am a localite.
From here?
From here only, sir.
Belgaum.
Belgaum,
So
sir.
what is your company? Which company?
HESCOM, Hubli Supply Electricity Company.
Hubli. Okay.
One of the DISCOM in Karnataka.
Discom. Again, Discom.
Good evening, sir. I am Sunil Kumar, working for a distribution company, Mysore.
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 Discom.
Sir, my name is Ravindra, working as executive engineer, Discom Gulbarga, Karnataka.
Discom Gulbarga.
Yes.
Good evening, sir. My name is Parameshwar Hegde, Mescom company, Bangalore, working as a accounts officer.
Discom. Most of the persons are from Discom or from policy making CA, right?
My name is Tanoj Kumar. I am from Central Electricity Authority. I was working in the sub-office of CA, RPSO, Regional Power Survey Office.
Where?
Regional Power Survey Office, North.
Acha, in Delhi.
In Delhi. I was working as Assistant Director.
Good evening, sir. I am Krishnakant. I am working in CA. I am also posted in Regional Power Survey Office, Kolkata.
Kolkata. Yes. Madam is also from Hubli, is it?
Yes, sir. Jyoti Revankar, AW, LDST, sir. SCADA, Integration Hubli.
Okay. Discom, again.
No, sir. KPTCL, Karnataka Power Transmission.
Transmission, okay. So can we start? My topic has been changed to BESS. My time has also been changed to today. But to integrate it with what we have been discussing, probably if we see things in totality, holistically, how our grid was and what it is going to be. We are in very exciting times. Times are changing very fast. Earlier it used to be either thermal or hydro. So if you can understand, with thermal you can have a grid purely based on thermal. If it is having capacities to run at lower capacity with not too much of efficiency loss, you can have a grid totally based on thermal also. If not very large variations in load are there, and your plants are also made in that way that they can work at lower megawattage. With hydro, even more flexibility is there. These were the two main methods of generation, apart from nuclear and others also, which were existing, but minor players always, except for grid like France, where nuclear plays a very big role. But in most of the grids, these two took the dominant role. If it was country like Canada or Norway, probably, or Brazil or many other countries, probably hydro was very prominent. And otherwise, thermal, in most of the grids, thermal used to be very prominent. In hydro, much more flexibility is there. So you can run a grid totally on hydro easily. And when it is mix of two, again you can run it very well. If you want to, again, if you manage your assets well, if you manage the demand also a little bit, and through minor adjustments, grid stability is no issue. But as I said, things are changing. Now we are trying to have renewable energy. Hydro is also now being classified as renewable energy. Earlier it used to get a bad name that this is also a polluting industry, but it is not. Not at all. So world over it is considered renewable. It is renewable and non-polluting. Solar and wind, renewable, non-polluting. So we don't want thermal anymore. Particularly, we don't want coal anymore, because coal is 40 times as polluting as compared to or even more when compared to hydro, solar, wind, nuclear, anything you say. What we classify as renewable and non-polluting, non-fossil generation methodologies. So that's why we want slowly all the grids with the protocols in place, UNFCCC, COPs, and lot of international hue and cry and mechanisms in place. Almost all the countries don't want polluting generating, except for few. Like when Trump comes, then probably America goes, talks of going out of that Kyoto Protocol and Paris, whatever they committed over there. But most of the countries, they are falling in line, and they have understood that these methods of generation cannot go on. So under these circumstances, when more and more solar and wind will be there, if I pose a question to you that can we run a grid solely on solar? only solar assets are there in the grid, and we want to run the grid. We cannot. Because if you imagine a grid with only solar, somewhere around 6, 7 in the morning, depending upon which part of world you are, or little earlier or little later, it will start ramping up. There will be no generation in night. So from evening hours, you don't have any electricity anywhere in the world. Anywhere in the world means where means if at a particular geography we are talking of, anywhere in the world probably is not the right way of putting it, but in a geographical location, when night hours come, there will be no electricity. We don't want that. In the morning, suddenly a lot of electricity will start flowing into the grid, and depending upon what period of year it is or what kind of cloud covers you will have certain generation. Then in the evening, suddenly it will start dipping and you are out. So it cannot run that way. Can we run any grid purely on wind? Again, we cannot. In a particular geography, there will be hours when there will be wind, say night hours or some other hours at times. So again, generation will be there during night hours when we probably don't need too much of energy, and rest of the time you just don't have. Can we run a grid in combination of solar and wind? Again, we cannot. We'll have generation in sunny hours. We'll have generation in windy hours, that is mostly night. But when we need it most, in the evening hours, there will be mostly no generation or very little of wind coming. In the morning hours again, when we need electricity, the morning peak, there will be hardly any generation, little bit of it. So now these are the circumstances. Means we want no thermal and we want solar and wind. So now you understand that hydro is required for a grid. We want clean energy, green energy. Hydro is classified as green energy. All these technologies, hydro, solar, wind, and nuclear also, and few others. Coal is 40 times as polluting, minimum 40 times. So we need hydro for evening and morning peak probably. So that is the importance of hydro in the grid. But hydro is limited. There will come a time when your grid is expanding, the requirement of load is expanding, hydro sites are limited. So again it will shortfall at one time. I am creating a scenario that all thermal goes out. All thermal goes out. No more thermal. And we have solar, we have wind, and we have hydro. So there will come a time that hydro peaking, even right now, hydro alone cannot meet peaking. Even if in India, if we exploit all possible sites, even then hydro alone, even at this stage, cannot meet the peak. Maybe 20 years back, hydro alone could have met the peak. But right now the demand is such that even though we have not even harnessed 1/3 of our sites, 1/3 of our potential. But even if we had harnessed 100% of our potential, like many developed countries did, almost 100. You can never say that you have harnessed 100% of your sites. So that is the constraint. Now what are we left with? If we don't want thermal in future, We definitely want solar. Solar is improving, efficiencies are improving. Over the period, now on its own it can stand. It is cheap enough to stand without any crutches, without any government support. Wind also, probably it competes well with cost less than thermal generation, cost less than hydro generation. So even wind is slightly costlier than solar, but still cheap enough. So we can have in future lot of solar, lot of wind, and we can think of putting thermal out of the picture because it is polluting. And hydro alone cannot meet the peak. So what are we left with? The options. If you can come up, if you can think, put your thinking caps and think of some solutions. Yes, who said that? You said that, yes. Nuclear can be one of the options. I said it is not polluting. There are apprehensions regarding safety, regarding how to dispose the nuclear waste and all those things. But again, probably research is going on, technology is improving. Even right now, with the existing technology also, probably we can have nuclear. Because nuclear also works as base load. So a lot of generation can come. The base load requirements can be met through nuclear. But India will have dependency regarding uranium. We haven't had any exploration in that regard that we have uranium anywhere in India. Till now, we have not been able to discover it. So that energy security will not be there. That will always be a. We do have thorium. We have, because we want ultimately if we want thermal out, nuclear is a way out, right? Your grid is very, very thermal heavy, not 50%, more than 75%. Generation wise, more than 75%. Install capacity wise, probably 50% approximately. But their PLF is much higher than solar plants and wind plants. Right. So their contribution in energy mix is probably 3/4. So if so much thermal you take out of the picture, your grid collapses, doesn't exist. So probably we can start over the years. We can reduce our dependence on coal. We can phase out old non-efficient plants slowly. When they become old, rather than refurbishing them, carrying them on, probably we can phase them out. But matching base load requirement should come from somewhere, something like nuclear, which has the attributes of, inertia and rotating mass. So, because again, it is basically steam turbines. Rather than burning fuel, you are having nuclear fuel, right? So, but even that doesn't complete the picture. Nuclear has its own challenges. Our experience with nuclear has not been very good. It takes a lot of time, unfortunately. World over, means plants have been delayed always for some reason or the other, particularly in India, and it will take a lot of time to kick in. It's very capital intensive, needs a lot of money. If you start today, probably the fruits will start coming after 15 years, or I don't know how much time it takes. So, any other thing, any other solution which comes to mind? Yes, storage. So I wanted somebody to say storage, so that I can come to my presentation. I am leading you all there, right? So if solar is cheap, if wind is cheap, probably we can have some method that in sunny hours, it's a sunny country. In sunny hours we have excess solar and somehow we can shift it to peaking hours, in the evening or in the morning. Similarly, if we can have a lot of wind in our coastal areas or offshore wind, or there are many other sites for good enough for installing wind farms. So if we can have generation in evening hours, night hours, and then we can shift it to morning peak or something. So there the concept of storage comes. Hydro by itself is beautiful but limited. So if I had a lot of hydro, probably I would have first gone for hydro because that is cheaper. Storage is not cheap. You will find that storage is not cheap, it's costly. But since hydro alone itself will not be sufficient, so there comes the concept of storage, and storage is a beautiful thing because it helps to have more solar in picture. Otherwise, solar will be limited to what my daytime demand is. Maximum if all thermal goes out. But with storage, I can have even more solar where I can store the excess solar in sunny hours for my evening peak. The storage is a beautiful concept for grid. Costs a lot because I'll come to that. The two major competing technologies are pumped hydro and battery. And both are costing more than 9 rupees, 8 rupees, 9 rupees, 10 rupees, depending on how you work out the cost. So you can get the idea, you get the drift that it is much costlier than any other method of generation because what you are doing, you are generating. Otherwise it is just generation cost. Whether it is solar, wind, hydro, thermal, whatever. If you are just generating, so what is the cost? Generation cost. 2 rupees, 3 rupees, 4 rupees, 5 rupees, whatever. But now when storage comes into picture, it will always be costlier than generation naturally. You first generate, then you store, then you again generate. So 3 times. The process becomes 3 times now. So naturally if generation cost is 3 rupees, you first store it, the cost of storing probably again is more than 3 rupees, and then you generate, then again the cost may be of the order of 2 rupees, 3 rupees, whatever. So naturally the cost is going to be more than 9 rupees. So that's the issue with storage. But there can be financial mechanisms, bundling it with the generation and making it RTC, making it FDRE, and generation as well as peaking. When they are bundled together, probably it comes within manageable range. So that is the importance of storage. So what are the attributes of storage? How does it help in making a robust grid? It follows generation. Usually what we are doing, we are in grid, we are trying to follow the demand. Right? It's a new concept now because generation is not in our control. Generation depends on Surya Devta. Right? Yeah, Varun Devta. So we do not know how much we will get. So generation is not in our control under this. Otherwise it was under our control what we generate. Here sunny hours will tell us how much generation we are getting. So now you have a load available in the grid. If more generation comes, your load increases to match the generation. Right? So the concepts are changing. Now you have an extra load lying with you, means flexible load, which you use when extra generation is there. And now this asset itself, the same asset, follows demand in peak hours. Now as the demand comes, you can inject power in the grid. So that balances the grid. The kind of flexibility which is there with hydro, pump storage is nothing but a form of hydro. When it generates, it's like hydro. Rather, the structures are like hydro. You are constructing a hydro project with not with one reservoir, but with two reservoirs. That's all. So rather than making one dam, you make two dams. I don't know, am I making myself clear or not? Because most of you come from DISCOM, probably CA people must be finding it easier. So DISCOM doesn't have the concept of generation. So probably I should tell what happens in pumped storage is, the concept is very simple. First, let me tell what hydro is. Hydro is the water cycle. Your water lies in ocean. What God does, again, to our rescue, what comes? Surya Devta. We are sitting in this room because of Surya Devta. All energy comes from sun. So even water cycle is dependent on sun. Sun comes up, evaporates the water from the ocean or water bodies. Clouds are formed. They go towards mountain. Precipitation happens. And from mountain, now that water has potential energy. It is at height. 3000 meters, 4000 meters or whatever. So what was lying at mean sea level, 0 meters height, now has the height of 3000, 4000 meters. We can exploit that potential energy. So what we do, we create a barrier in the stream, which we call dam. Water heads up behind the dam. A reservoir is formed. Now that stored volume is there with us, which we make it flow through a pipe called penstock. Thereafter, turbines are there, depending upon what the head is. So, Pelton or Kaplan or Francis turbine is there. And turbine rotates. Along with it, rotates the generator through coupled shaft. And when generator, that rotation is there of rotor, around is, if you can remember, most of you are probably electrical engineers. When stator is there, so electromagnetism gives us power. Right. So same thing happens. Why I told about hydropower? Because same is the concept with pumped storage. Now what we do, we have two reservoirs. Earlier we had one reservoir. We were holding the water which was coming from mountains. Now we are not dependent on mountain. Anywhere where we have elevation difference, height difference, we can create two reservoirs ourselves, on our own, anywhere. So anywhere in the Western Ghat, anywhere in the Deccan Plateau, anywhere in the Vindhyachals, where we can locate two reservoirs after creating some dikes, some small dams. If we can create two water bodies, we can connect them through a pipe, and in between we can have a powerhouse, which we call. Let us call it powerhouse, but this powerhouse, the powerhouse does two jobs. It is also a pump house. When you have excess energy, you have now excess electricity with you, excess power. So the same machines, now what we were calling earlier generator, now that becomes motor. Now you are giving it electricity. You are making it rotate through electricity. So now it is not a generator. It is a motor. The very same machine. Now that motor rotates the turbine. Earlier what we were calling turbine. Now that turbine is not turbine. Now that is a pump that is throwing water upstream. The same machine. It is important concept to understand that these machines will remain same. We need not place two machines in the system. Now the pump has pushed the water in the upper reservoir. What is happening? I am following the generation now. When excess generation is there, more than the demand in the grid, I use that excess power to pump water up my upper reservoir, from the lower reservoir to the upper reservoir. Now in the evening, my water is stored there on the hill. Now in the evening, when generation is not there or less generation is there, but demand is more, now we are into peak hours. So I make that same water run through the system again under gravity. Now that what I had called pump is now my turbine. That water makes it rotate. Now that turbine was, of course, coupled with what I had called motor. Now that motor is turning because of that flowing water. That motor is now my generator. So it's that simple. So this is the concept of pumped hydro. It has all the attributes of hydro. What are the attributes? It doesn't need anything much like a thermal power plant. To put up to bring thermal power plant into generation, you need a lot of energy beforehand to make it run. There are various systems which are asking for a lot of power. So you need to have some power source beforehand to start the thermal power plant. It takes 1 day or 2 days time to come to power. But what happens with hydro, or for that matter with pump storage? It doesn't require much energy. It means it doesn't require any fuel, any boilers to fire, any coal handling, ash handling, this handling, that handling, cooling water, flue gas system, this system, that system. Tens of systems are there in a thermal plant, which all require energy by themselves. Hydro is without any fuel. Means water, falling water, if you can call, that's not a fuel. So not much energy is required to start the hydro plant. So this is an attribute of hydro or pump storage. When we want it to start, so that is called black start capacity. When grid fails, खुदा ना खास्ता किसी वजह से सारा ग्रिड फेल कर जाए, बिकॉज फ्रीक्वेंसी डाउन हो गई, वोल्टेज डाउन हो गई, लॉट ऑफ जनरेशन आउट हो गया फॉर वॉट एवर रीजन, और ग्रिड फेलियर हो गई. If I break into Hindi, does everyone understand Hindi, or should I stick to English? Is there someone who is not comfortable with Hindi? All are comfortable with Hindi? Sure. Now we are a nation, two languages join us, English and Hindi. Right? So, anyways, coming back to it, so this is one attribute. Another attribute is its ramping up and ramping down rate. It's not like thermal. As I said, that all thermal plants, if it's a 100 megawatt machine, the moment you bring it below 70 megawatt, you ask it to run at lower megawattage, the system starts shaking. Whereas this has much more flexibility. And it doesn't take much time to ramp up. Means if you are at 0 megawatt and you want to go to 100 megawatt, a thermal plant will require a lot of time. This takes minutes. Black start was another thing, right? This is another thing. I told you that in the morning, a lot of solar starts coming into the grid. With the solar heavy grid, a lot of solar starts coming into the grid. Now what you need a source which can back out at the same rate. Hydro and PSP have that capacity of ramping down. The way sun is coming up, with the same rate, we can lower the generation of hydro resources. hydro and pumped hydro. In the evening hours, reverse happens. Now what is happening in evening hours? If somebody can tell? Solar drops. But load remains same. This solar was meeting that load. Right? The load was of the order of say 200 gigawatt. And this solar was a lot of solar was kicking into the system. Apart from base load stations of thermal or nuclear or whatever. So now that solar is going out. If I don't inject equal power in equal measures, the grid will fail. So it has to meet that rate at which solar is going out. Something which has good ramping rate. So there also the hydro assets, hydropower plant and pumped hydro, they come into picture. They can match that. If solar is going down like this, the hydro assets are coming like this. So they are balancing. The grid is balanced. So my point of repeating all this, probably many of you know this, but saying it again, probably you must have heard it all before, but you have to understand that for grid stability, with the kind of grid that we are having in future, these are required. So another, if we have understood the concept of pumped hydro and its importance, there are other storage methods apart from pumped. Right now in the world, most of the storage is in pumped hydro space, more than 95%. And this is not new technology, this has been existing for last 70 years, 80 years. And this has been working beautifully in US, in Europe, in Japan, now in China also. So it's a proven technology. But is it the only storage technology right now? If somebody can throw light, because storage is as much more of DISCOM asset. It can be classified as generation asset. It can even be classified as transmission asset. But I believe it is more of DISCOM asset. So most of you are from DISCOM. So probably you must have heard of some other storage technologies. If somebody can come up with few ideas. Battery storage, BESS. Out of the energy storage systems, pumped hydro storage system was one, battery energy storage system, BESS, which we call in short. Again, many technologies are there, various types of batteries are there. But are these the only two, or do we have more? Hydrogen can be used as energy storage method. Very right. Most of the people are still not keeping the hydrogen option into the picture. Because they hear of the hydrogen, but they don't understand hydrogen also is, in a way, method of storing energy. We have to now understand, we have to change our minds, and we have to start calling hydrogen technology that we are talking of is nothing but a storage technology. We have electrolyzers, we send electricity, water molecule is broken into hydrogen and oxygen, and we can use both gases for our purposes. Oxygen is also required in many industrial applications, or probably as you saw in COVID, at that time hydrogen became scarce and so precious that people lost lives because of lack of oxygen. So apart from that, hydrogen is a energy storage device, because hydrogen itself works as a fuel in many industries. But apart from that, if you have fuel cells, electrolyzers broke that hydrogen molecule, water molecule into two gases. Now through fuel cells you combine, and in the process you get the energy back. So it generates electricity. So first we stored energy by breaking the molecule, then we get back the energy through fuel cells. So hydrogen can be one method of storage. Yes, definitely. Anything else?
So since we're talking about PSP, pumped storage, and as you said that it is not necessary, it has to be a natural run-of-river pumped storage. We are also looking forward to creating some artificial pumped storage power plants. What will be the cost implication, and do we actually have enough water available to fill in a reservoir? This is one, if we are talking about the ghats or any plateaus or anywhere. As of now, seasonal rivers are also going dry at this point of time.
इसको ऑफ कर रखा है आपने? चलो थोड़ा इसका टेम्परेचर 30 है, डाउन कर दो आप. Just a minute, it's very hot here. 30 यार हम लोगों की 30 में तो गर्मी हो रहा है सर्दी. You'll have to repeat the question, sorry. Please repeat again.
When we're talking about pump storage plants, and specifically artificially created pump storage plants, we're talking about creating a reservoir, then followed by arranging for water resource for filling up that reservoir, which is again artificially created resource at that point of time. And in our country, as we see water crisis in most of the parts in the summer season, when demand is at its highest or the load growth is actually seen in the summer season. Where are we getting the resources from? Land acquisition, is it still a problem for artificially creating these PSPs? And third question, when we are already struggling in the summer seasons with our load growth curve across the country, last year we've seen, for pumping up that particular energy, we are using electricity. Who's determining the tariff and how much, even if we're using surplus in the solar hours? During summer season, the solar hours is also peak due to the AC consumption with the standard of living and GDP and everything increasing. How are we compensating for the energy that is being used to pump up that water again to create electricity? And is it actually like impacting the cost viability of that particular PSP?
Very, very relevant, very valid questions. Like always, Divya comes up with very, very insightful questions. Pumped storage can be made in many ways. It can be made on stream. Water is flowing in a river. We put a barrier there, a hindrance, which you call dam. Water heads up behind that dam. So one reservoir is created, right, in the river itself. Hello. हाँ नमस्कार. हाँ बाब ना अभी मैं नो So we are talking of on-stream pump storage. We can have another reservoir also in that stream, because stream is going down towards the sea. So at some other elevation again we can have reservoir. So both the reservoirs are existing on stream. That is one way of making pump storage. And both can be generating stations also, because again water is flowing towards sea. They can be pumped storage also. They can be hydro generating stations also. Another way can be one reservoir exists on the stream. Another one I create artificially somewhere high up in the mountain. Right? then I have a reservoir existing on the river. I take this water and I throw it up on the mountain top or some plateau on the mountain, some 500-600 meters up. So these are on stream. At least one reservoir is on stream. I need not have any reservoir on the stream. Now comes the concept of off-stream. In off-stream, what I am doing, I see around in Deccan Plateau, on the Western Ghats, in the Vindhyachals, river is not flowing on all the hills. Means that runoff somewhere in the valley converts into a river. So I have a hill. I find that I have two plateaus, two relatively flatter areas, and only in monsoon water drops on the hill. So these are not perennial rivers we are talking of. These are not even perennial streams we are talking of. We are not even talking of streams. Means practically some runoff happens on those small hills. So these are totally off stream now. No stream is being impacted with it. I am creating artificial reservoirs because I find that some undulating land is here on the hill. This is a hill and some land is here. I put a dike here, or I create a ring bund over here, or I put a dike there, or I create a ring bund over there. So these are artificially created reservoirs. So with this system, what comes to me? A lot of flexibility where I can place my reservoirs. So I place my reservoirs where there is no population. Not much impact is there on the population. I am independent of, now I can choose my sites. So I need not place them where the towns are or villages are. I need not place them where a lot of cultivable fields exist, where crops are there. I do not place them in environmentally sensitive areas. I put them away somewhere. I find the location, because many such, thousands of such locations for off-stream, for on-stream hydro stations or for PSPs, sites are limited, fixed. Those are site specific. God has created those sites. We cannot create hydro power plant anywhere. I cannot say tomorrow that let us put a hydro plant in Belgavi, because site is not there. Whereas pump storage, off-stream pump storage, we can have thousands of sites we can find in India. So I have a lot of flexibility over there, from environment angle, from R&R angle, rehabilitation and resettlement. So land acquisition becomes easier. Environment clearance becomes easier. That's probably settles a part of your question. Secondly, how to fill those reservoirs. Maybe the rainfall that is coming, or the runoff, small runoff that was being generated, will not be sufficient to fill them in one season or even 2 seasons. Under the circumstances, I can always find some stream nearby, because in the valley down there will be some stream which is of good amount of water is flowing there. Exists for irrigation purpose or for water supply purpose. State government is having some reservoir. So I can approach the state government. Either I can fill from the stream, I can lay a pipe, and or I can take from that reservoir if state government allows the water supply or irrigation. Now comes, there is water scarcity. So taking water from the stream, somewhere the water which was probably available, again, truthfully speaking, a lot of it goes into the sea ultimately. But maybe water is scarce in some area. So For these reservoirs, not much water is required. First of all, we have to understand not much water is required. You have to understand. Hardly 200 meter by 200 meter and 20-25 meter height. So the amount of water which is required in terms of storage is not much. The reservoirs are 100 times bigger than this. So what we will be drawing is a very small portion of it. Or if we take it from stream, a lot of water will be, much more water will be. I mean, it's like taking few drops out of a lota. So in a season it is not going to affect much. Now I have filled it, so I need it again and again. No. What I told, very little quantity of water is required. Topping up, I will require only 200 meter by 200 meter by 1 meter. These are not heavy demands of water, very little water. In terms of the kind of runoffs we have, this is very little water. So that apprehension that where the water will come from, the requirement is very little, and once you fill it, you need very little to top it up. That again, probably monsoon can help a lot in that. So that apprehension again is probably, it's nothing serious. Water demand is not much for pump, because the same water is being pumped up hundreds of times, up, down, same water, right? So does it settle both of your questions, or was there anything else? Is it too heavy? What I am telling, most of you, are you able to understand, or is it too much? It's okay. I will ask questions at the end. Right? If you are saying you understood. So, but anyways, it's not a classroom that way. So I hope you understood. How much time do I have left? I can continue. So, storage technologies we were talking of. You told very rightly hydro. So we have talked of two till now. Three? Which one? First? PSP first.
Then battery storage and
hydrogen. Right. So that's the third one. Anything else?
battery storage, battery energy storage systems. When we're talking about lithium-ion battery, the technology, or we have an option of sodium sulfate. Right now, mostly everybody is going for lithium-ion due to its efficiency and
energy density. Energy density is very high, very popular. Lithium-ion everywhere you find it. Grid scale storage to your mobile. Everywhere lithium-ion is very high because of energy density. But lithium is a scarce commodity.
the question is, when we go on a flight, if we have a lithium-ion battery power system, they don't take it on the flight because of safety issues. If it catches fire, there is no way you can stop the fire on a lithium-ion battery. When we are talking about huge spaces being converted into lithium-ion battery storage systems, right next to our power plants, who is doing the regulatory safety compliances in terms of lithium-ion battery storage systems? Second, when we are talking about the distribution company starting to have obligations of storage, where is the cost, initial cost? Who's bearing the initial cost? Is it the generator? Is it the distribution company? Because eventually it has to come to the consumer. Be it you add the generation tariff or you add the discount tariff, it has to come to the consumer. But the initial front of it, where the financing has to be done for the energy storage system, who is bearing that cost? And who is doing that particular financing in terms of storage systems?
First of all, safety issues. Yes, a lot of research is happening in energy battery space. So there are technologies which are much safer, but the cost is right now prohibitive and very high. You can go for solid state batteries, which probably have good energy density, very good energy density, and much safer, but are much costly. So ultimately it boils down to money, right? So you have to place your battery system taking safety aspect into consideration, right? You cannot place it somewhere where some flying object will one day pierce it and probably will result into fire and explosion. You have to place it with sufficient coverage and in a place where it is not subject to any such eventuality.
The kind of forest fires that happen across the country, which place is safe? We're using wasteland for setting up solar. We're using wasteland for setting up wind. In summer, peak summer, there are forest fires with spread happen. This is just one of the instances. There might be more. How do we prevent such instances, natural instances? We're not saying an aeroplane will crash into a battery, but a small forest fire or a small instance of common mishandling of any fire substance. How do we prevent this? Do we have any insulator around the batteries or any of such precautionary measure regulations? Are there anywhere approximately?
The way I said in the beginning, that you place them intelligently. If you have some industrial plant running nearby where you are supposed to have some storage system, you try to take land away from it, right? Not right next to it. Again, cost issues and all those things are there where you are taking land. Not much land is required for that. So you can always place it after seeing the surroundings, what is there in the vicinity. If at all you are still apprehensive that your battery assets may come under fire, whatever, you can always have a cleared area around, no vegetation, right? You can have concrete wall around it if you are still more apprehensive. So depending upon in what kind of environment you are, I am talking of grid scale batteries, right? Grid scale storage through battery system, not at small scale kind of thing, because batteries are everywhere, so we have to keep the perspective in mind. So you place it intelligently with all proper precautions and safety requirements. You can as well have a concrete wall around it. You can have access control. And the lithium ion now is not that dangerous that any day it will all of a sudden catch fire. The way it is being manufactured, in the beginning, there were issues. And whoever tried to cut corners, those manufacturers were thrown out because nobody know, if we talk at smaller scale, say mobile battery, no mobile manufacturer will compromise on safety there. There were instances with company like Samsung. They found that in China somebody is supplying cheaper battery and it looks very beautiful and it's a big setup, and they showed that our technology, we have found a system of more energy density and we have this quality control, this. They fell for it. But the moment few incidents happened in few of the sets, they immediately threw that manufacturer out. They had to cut a sorry figure, means they had to somehow quench those fires, otherwise their reputation goes down. So only the good manufacturers were left. Apple will not go for after compromising safety. If a battery is cheap, they will not buy it just because it's cheap. For that matter, Samsung or anyone, Vivo or Oppo or whatever, Xiaomi or anything. So similarly, means technology has improved. Safety is a concern. If in my pocket, I am afraid that this may blast any time, so I will rather not use mobile phone. No. If few incidents happen, it's very, very convenient, probably cannot live without it, but if it comes to life, probably I will say that. So it has to be safe. It is that safe that I am carrying it in my pocket. And in aircrafts also, means after they screen it, they shouldn't allow, probably it's very difficult, cheap batteries. What is dangerous is cheap batteries. Right. For grid scale storage, I believe that everybody will go for good quality batteries, and in future, probably much better technologies are being researched and on the verge of becoming viable. Like solid state is one, but it's very costly, and many other technologies are being. Not battery storage is possible in scores of methods, means a lot of chemistry exists there. So a lot of research is done.
So final question, I'm so sorry everybody. When we talk about bidding.
Your questions are answered, or there was another question which remained unanswered? Because you asked them in pairs.
Yes, sir.
So I handled one, I forgot the another one. So there was another question or no?
I'll join it with this question.
Okay.
So final question, when we are talking about bidding in solar.
Your costing, cost issue, please.
The cost. When we are talking about solar bidding, now we will eventually come to battery bidding also. Like it was said in the morning, reverse bidding is a better option to promote competition and provide a better platform. If reverse bidding happens to be introduced in the battery BESS, will quality be compromised?
Yes. First of all, who bears the cost? Right, that was a question. Technology is playing with us.
By the way, batteries are in use in a number of industries. Ships have batteries. There are safety issues. What is to be done on safety is not completely unknown. There is an act called the Explosives Act, which is applicable wherever anything which has a potential of exploding. That gives some general instructions. So there are many industrial establishments where batteries are used.
Batteries are everywhere. Now batteries are all pervasive. You have them everywhere. Your watch, your mobile, your inverter, your household, batteries are everywhere. So safety is being taken care of. Means slowly those who are unsafe, they go out of the system. And better technology takes over. Always better technology takes over. So improvements are happening on real-time basis. Cost. Battery, I believe, will always be storage. I believe is mostly a DISCOM asset. Whether it is considered as transmission asset, whether it is set up by generators for improving their efficiency or whatever, the cost will always flow down to consumer or to the government if they are giving subsidy, and through government to consumers. Money has to come from somewhere, so we can assume that whether it is treated as generation asset or transmission asset, or mostly it will be DISCOM asset, it will be passed on to consumers. Right? Was that the question? Who will be financing? Who will be financing? Whoever will be financing it, generator will be setting up the battery systems for improving their own generation. If I am a solar generator, I am a wind generator, I am a hydro generator, and I need to store the excess. I need to make it RTC. I am taking on bulk consumers, C&I consumers, and whatever. I need storage, so it becomes my asset. Because I want to give FDRE or RTC, and I go for hybrid systems. But that costing, when I do the bundled cost of RTC, it will be carrying the cost of storage. That I will not do out of my pocket. So now, ultimately it is going to DISCOM along with the cost of storage. And DISCOM, what will they do? If an ideal system exists where no cross subsidies and no subsidies are there, they will pass it on to consumers ultimately, right? So whoever owns the asset, ultimately it is going down to the consumer. And beyond that also you had a question, I don't know. What was the question? Was that the final? No. I am looking towards him that he usually asks the questions. So let us have some question from participant also. So madam asks a lot of questions.
No, sir.
But whatever, not necessarily. Means
I'm just answering your question, sir.
Yeah, please. Carry on. You can see. You need not always ask questions. Right? These are evolving bits. The system is dynamic. Your thinking cap should also be on. If you come up with something, you are thinking of something that this can be a solution. Don't discuss, if not asking questions, and I will not have all the answers. Because these are all new, some 10 years back, these things have been introduced. So we are still struggling with these systems, learning, knowing them and learning and then trying to find solutions. So we may not have all the answers at that. So you are the people who will have answers in the future. But right now, you are also engineer. Keep your thinking cap on and add on. If not asking question, discussion. You can have discussion or contribution.
One more storage device, a flywheel, I think. Flywheel mechanism.
I wanted to ask that what flywheel. China is now constructing flywheel. When they have excess power, they are making flywheel rotate. When they need power, they suck it out of the flywheel. Very important storage technology. It has its own attributes, right? It has inertia.
Yes.
So that there are many others. Probably I don't know how much time I have. I would like to touch upon a few others. Do I have time? Compressed air. You compress the air. What you are doing with your energy, you are running your compressors and you are compressing the air. And when you need power, that compressed air becomes your prime mover. Right? So you have caverns deep down in the earth. Right? That rock mass around it is your storage system. So you excavate, you go 200-300 meters down in the earth. Right? You excavate. So now what you have in the below the earth, a cavern, an open space. And you send air into it, you compress it, and now when you need the power, that compressed air you draw again, and it makes the turbine rotate and generator generates. So compressed air is one method. It has its own challenges. It has its own challenges. A lot of heat is generated in the process, how to dissipate that and all those things. So still evolving, still evolving. Any other method you can think of? You have to think of energy forms. In what forms energy exists. So now I am trying to convert electrical energy into maybe some other, I converted it into potential energy. I also talked of chemical storage, battery and right. Heat is also a form of energy. If you remember our class 10 physics, we are all engineers and come from scientific background. If you remember class 10 physics, heat is also a form of energy. Like potential energy, like kinetic energy, like electrical energy, heat is also a form. So what I do, I take some substance which has lot of specific heat, like soil. I heat it up to 500, 600 degrees, so that molten salt, now becomes my heat source. When I have excess energy, I heat it up. And when I have to generate that molten salt, can create steam and I can run a steam turbine. Is that okay? You were saying something. So solar doesn't mean only PV. Photovoltaic is a very good thing. Very easy to install and everything. And proven now, proven technology, because if you take care of your solar panels, keep cleaning them, and not many bird droppings are there, not many are breaking up. Basically, these are being managed well. It's a proven and efficient and cost-effective technology. But that is not the only way. The sun is giving you photons and light. It is also giving you heat, which is a problem in PV. Because your panels heat up, their efficiency goes down. But if you are having a big mirror, not 5 meters or so, 150 meters here, 150 meters all around, a circle in the shape of a bowl, right?
Concave.
Yeah. Concave. Right. And in the center, at the focus of that concave mirror, at the focus, you have your tower, and on the top of that tower, that is falling in the focus. If you are having if you are having salt, with all that heat, it will become molten. If it starts storing energy, it will heat up to 500-600 degrees, and in the daytime. And in the night time, out of that heat, you can create steam, and you can have your steam turbine temperature. So molten salt is also a storage technology. And then probably there can be many more, which few of us we are exploring, and many more will come into picture. So ESP and batteries are not the only option. Flywheel is very good. Hydrogen right now costly, so hopefully it has its own application, but hopefully it will become cheaper. So right now the cheapest two competing good technologies are ESP and VES. Right? So I don't know how much is time now. Yes. So can we have question and answers if any more, and then probably I can wind up. I had some 50-60 slides which will take a lot of time to go through. I don't know, I am the last one, so hopefully we can break in time. Any other questions?
Sir, in the concept of the smart city and smart grid, we are having a concept like electrical vehicles are supporting the grid in the terms of the peak hours. Electrical EVs, electrical vehicles, EVs are supporting the grid in the time of the peak hours. So theoretical concept. It's theoretical concept. Yes.
Very good concept. See.
So do we consider that as a battery storage system?
Yes.
It's not a direct battery storage. It's indirect battery storage. It's not direct.
Battery storage. If you have the systems in place, I often think that if we had not thought of thermal generation and hydro generation, if our first understanding would have been PV, that we can have electricity through photovoltaic, our grids would have been very different. Our grid would have been very different. There would have been local generation, local aggregating, and local supply. And probably through direct, our equipment would have been direct current equipment. Probably at lower voltage, I don't know what would have happened. Right? Now what happens when we have the legacy of this grid? What is this grid? It has concentrated power generation, huge power generation at certain locations. Now to send it to the consumer, we have to have a lot of transmission. Right? But we know that distributed generation is happening. If you are thinking of rooftop, what I think, again discussion mode probably, you should have your thinking cap on. We are asking everyone to have rooftop PM Surya Ghar. Now, individually people managing their own system, which is possible. But then again, you are breaking it down to such a small level that maintenance and cost of maintenance probably goes up. Local aggregation, probably that is the right word, locally aggregating that power in a village or in a locality, one person should be there. I should be able to lease out my roof space to him. And probably I should build my houses in such a way that you can have access to that rooftop without disturbing me much. And he aggregates all that power. He has his batteries or any storage system. He has his inverters. So now he is able to maintain it well. Are you getting the concept? Some 3,000-4,000 rooftops, he is getting the power. Right? And he is maintaining the system. And he is probably supplying to those houses also. Because he has some storage with him. Whenever he falls short, if that area is not having sun for whole day, how much storage do we have? You cannot have indefinite storage of supplying for 4 days or something. So at that time, this centralized generation has this micro or mini or whatever, localized or distributed. I am coming to your point also. These are again thoughts. Now slowly we will have no ICE engines. If you are that serious about climate change and or not polluting, they are also, if not as much as power generation grow, maybe not as much as industries. Equal polluter is the transport sector. Almost comparable, matching. Right? So there also we should think of taking these polluting technologies out. If I am generating through solar or wind and I am able to have a lot of electricity, then my vehicle should move on electricity because this is green. So no petrol, no diesel, nothing like that, no gas and at that time, all those vehicles, whether these are ships, whether these are trains, whether these are heavy trucks, whether it is an SUV, whether it is a car, they will be having battery in them. Right? That is also storage. Right now that battery does what? Takes the vehicle somewhere and brings it back. If I am putting electricity into that battery, when there is less generation, maybe I am not taking my car out every day. A lot of cars will have excess power, they can store in the daytime and in the evening time they can give back to grid. A lot of capacity will be created if all the vehicles convert into EVs. We have huge storage system. If we add all those battery capacities, because future EVs will easily have range of 600 kilometers or so. They will have to have, right? They are having sufficient capacity. They can power the house easily. If you have a good sized SUV with sufficient range, that battery, if your load is not too heavy, means 6 AC and diesel and washing machine, all everything running, you are wasteful. If you are a normal consumer, that battery will be able to run your household for the whole day, probably for 2 days. But if you consume probably more judiciously when sun is not there and you become more judicious probably for more than 2 days. So that much capacity lies in those batteries. I have to create the system. I have to have the enabling infrastructure, enabling policies. When Electricity Act was made in 2003, who had thought of battery systems? BESS word, battery energy storage system word didn't exist. You read whole of Electricity Act, you will never find it anywhere. So there are the policies in place. We have to create policies for changing technology, for changing grid, for changing environment. Distributed generation, you have to have policy for that. Microgrids, you have to have policy for that. Grid, your microgrid having excess generation given to grid. Your microgrid having less generation drawing from the grid. That microgrid being treated collectively at one place. And that person who is running that microgrid, handling the consumers ahead. Where are the laws for that? Where is the policy for that? So what you are saying is very much possible if we have enabling infrastructure and enabling policies. Right? Lot of storage capacity will exist in your EVs in next 20 years. As the ICE engines go out, internal combustion engines, as they go out, as the vehicles convert into EVs, lot of capacity will exist. We have to learn to use that capacity to our advantage. Right? Any more questions?
Sir, what are NHPC initiatives on floating solar?
Our initiative, particularly NHPC.
Yes.
We are constructing a floating solar in Kerala. We are in advanced stage in Odisha. Two floating solars. One is under construction in Kerala. Two are almost lot of survey and advancement in Odisha. And we have lot of states have been indicated to us where we are conducting surveys, looking for water bodies which are amenable to floating solar, and whatever we find, if the body is good enough for setting up floating solar, then we will.
Sir, are you going to convert all the dams into the floating solars or something like?
Technically possible, but few of the dams where a lot of variation is there.
That's what.
Water goes up and down, lot of variation. But if it is in manageable space, then most of our can be followed.
So the floating solar was electrification. Does floating solar was algae and the impeding length?
Yes, there are studies like that, but you have to have friendly technologies, right? There will always be challenges and you have to find solutions. You will have products, organic products, which you can put in water periodically and arrest the flow.
It is stopping the penetration of the sunlight in a particular water body.
That is a lot of advantages. On the one hand, environmentalists will say that there are some vegetations inside the reservoir, right? and these sun rays are going inside and they are purification or whatever they call it, and some methane is being formed. Right? If sunlight is going in. If it is not going in, then they will say that algae, fungi or whatever is going, and I don't know much of biology and all this, but then they will come up with this. Floating solar has a lot of advantages. If you put it on, I would not call it floating, but if you cover canals, it is floating solar. So you are reducing the evaporation. You get more water. Similarly, in other water bodies also, whether it is for supplying water or irrigation or air. So you can reduce a lot of evaporation, and if not much sunlight goes in, then again whatever vegetation is there under the reservoir, it doesn't. So I believe floating also has to advantage. Another question? Thank you.
Thank you so much, Mr. Batra, for this amazing presentation. And I now thank you all for sitting throughout the day and attending all the sessions. I hope